Pitch means the distance between two rotations along the direction of the magnetic field is said to be pitch. The electric field is said to be supplied. Since it is alternating current, its polarities keeps on changing. V is equal to omega into r, that is V means linear velocity is equal to angular velocity, the product of angular velocity with respect to the radius. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 2 of chapter 4, Moving Charges and Magnetism. In today's concept, in the previous class we had studied about the introductory part of this moving charges and magnetism. Now we are stepping on to the magnetic field. How exactly the motion takes place in case of the magnetic field, the movement. Okay. So now suppose if you're considering a particle of mass m and it has got a charge q with certain magnetic field within it. How will you give the force to it? So the force is given as F is vector quantity is equal to q of vector v into vector b. This is the magnetic effect what you give for the force. So getting on to its magnitude, what is that you get? You get the magnitude of this above equation as QVB. Since it is the theta which is acting at 90 degree, right angles to each other, the force is right angle to the magnetic field. So it is said to be theta is 90 degree and sine theta is said to be 1, wherein you just replace your F is equal to QVB as it is. And you know that the motion of an object will be taking place in case of the circular path due to the effect of the magnetic field. Okay. When the force is perpendicular to vector field, that is the magnetic field, the force acts towards its center. The force acting towards the center causes the centripetal force. Suppose if you are taking a circular motion of a particle, the centripetal force is acting towards the center. That is why it is known as centripetal force. Then according to this centripetal force, we have got F is equal to mv square divided by r. So we have equation 1 and equation 2. Equate 1 and 2 because both are F and F terms. So I can just equate it as mv square divided by r is equal to qvb. V cancels with v. So we have r is equal to mv divided by qb, or V is equal to QB divided by QBR divided by M. So this is the radius as well as the velocity concept what we have now. Suppose we consider, since it is taking a circular path, so a particle, it is taking a circular path and this is the center. So it has got certain radius and there is a magnetic field which is acting at this on this particle which is having a mass m, and the force as well as magnetic field is said to be perpendicular to each other. This was the concept. So now we have two forces, we have equated it, got r as well as velocity. Since it is taking up the circular path, it can be given as V is equal to omega r. I hope you have seen this equation which is very important equation, and it gives the relationship between the linear velocity and the angular velocity. This you had studied in your first PUC chapters. V is equal to omega into r, that is V means linear velocity is equal to angular velocity, the product of angular velocity with respect to the radius. So V is equal to omega r. So omega becomes V divided by r. This is other set of equation. Now we know that angular velocity is equal to 2 pi nu. Angular velocity is equal to 2 pi nu, where nu is nothing but the frequency. So frequency what it takes up during its rotation is what you have here. So omega is said to be V by r is equal to 2 pi nu, and we know V is nothing but QBR by M. So QBR by M into r cancels, we have 2 pi nu. So nu is equal to QB divided by 2 pi m is the frequency when it rotates. If this is a frequency, okay, so what is the time period? Time period will be inverse of nu. Time period is inverse of nu, okay, which is equal to time period T is equal to 2 pi m divided by Q divided by QB. So this is all about the time period, okay, and there exists something called as pitch. Pitch means the distance between two rotations along the direction of the magnetic field is said to be pitch. So for example, for that you can give the diagram as, suppose if these are all the magnetic fields which is moving in this direction, call it as magnetic field, and there is a rotation, this is one rotation, this is another rotation, this is another rotation, this is another rotation, and keeps on moving. This is a rotation of a particle. If suppose you consider a particle here which is even moving, okay, it keeps on moving. These are the dotted lines which shows its movement, okay, along the direction of the field. And what is the pitch? Pitch means from this part to this part, from this, that is called as P pitch. Okay, so from one rotation distance towards the other distance, other ring like a structure, that is from one loop to the other loop, it gives the pitch. Okay, the distance between two rotations along the direction of the magnetic field is said to be the pitch. So now, because of this equation, we can consider larger the momentum, larger will be the radius. Okay, so larger the momentum, that is mass into velocity is nothing but the momentum. When this goes here, it becomes momentum. If momentum is larger, the radius is also said to be larger. So for a circle with higher radius, the momentum is also said to be very much higher. Okay, so now if you consider the radius will be at the center of this loop. So this is called as, this is said to be radius r. So that is all about your motion in a magnetic field. How does the particle moves in case of your magnetic field? So this is a concept what you have to find out, wherein you have the equation of frequency and time period what you have to remember. So next we are coming to motion in a combined electric and magnetic fields. That is, we are just introducing a velocity selector. Suppose if you have any of the events, it is like you get selected, okay? So after your higher studies, you write the exam, competitive exams, and it is like best suited for the fittest, survival of the fittest, okay? Only the fittest and the fine people can survive in certain jobs, or certain, if suppose you're writing your CET exams and finally you end up in medicals or engineering like that, okay? So what is it called? So the best you try and finally it will be the survival of the fittest. Only the fit persons can survive there. Similarly, here we are checking out for the velocity selector. Only certain charges which has got certain velocity is said to be collected or is said to be used. Okay, you have got few of the applications which will be done in the third session of the same chapter. Okay, so it is like now we are considering a velocity selector. You are selecting a velocity of a particle. So now in order to calculate the velocity selector, we have a thing, that is we will have to consider, okay, so when a particle which is having a charge q and mass m is moving with certain velocity, there is an existence of electric current. That is, we are studying a chapter moving charges and magnetism. That means the charges is said to be moving, because of which there is an existence of magnetic field. Okay, so suppose if there is a moving charge and which has the charge q and mass m, it is moving under certain velocity v, then according to Lorentz force, or according to the force of the electric field as with respect to the magnetic field, we have force is equal to the charge into electric field plus the charge into vector v into vector b. You have dot product as well as the cross product, both of them have been summed together. Okay, so you have these two things. So for example, if you consider the axis, that is, if suppose there is voltage in case of your x-axis, and you have in case of y-axis the electric field, and z-axis you have got your magnetic field. Okay, so these are the vector condition. In x-axis you have velocity, y-axis electric field, Z-axis it will be the magnetic field. When this is a case, you can just give the coordinates or the components of x-axis, y-axis, z-axis. So velocity can be represented by velocity v can be represented in terms of x-axis with I units. Okay, that is I unit vector. So this can be rewritten as V into I cap, and your electric field is given as E. In case of y-axis it is represented, so it can be given as E into J cap. And finally, it is the magnetic field what is given, call it as B vector, which is equal to all these other vector quantities in Z axis, and you have got your B into K cap. So these are the quantities whatever you have. Now, consider this thing, that is the electric field force, okay? The force due to electric field is Q into vector E, okay? Now in the place of vector E, substitute Q into what is E? You have E into J cap, and this is one force. So call this as equation 1. Similarly, consider the other one, that is F is equal to Q into V vector into B vector. Okay, so the magnitude of this will be Q, V, B, that is given by, you have Q, V, with respect to V, we have I cross, what is B, with respect to we have K cap, okay. So I and K cap, so you know according to the cyclic order, I, J, K, I to J, J to K, K to I. So in this direction, it has to go from I, J, K. But this is I into K. That means it is a reverse direction. I into K reverse direction. So which is the remaining one? Minus J. Okay, J is the remaining one. So give it as J. This is by using the cross product rule. Suppose if it has I into J, you have to write K. If it was J into K, you had to write it I. If it was K into I, you had to write it J. It has to go by the cycle effect itself. Suppose if it takes clockwise direction, that is I into K, it is taking this way. So I into K remaining is J. J will be negative. So Q, V, B and negative of J cap. So this is the condition what is that you are having. So now the concept comes out to be F is equal to, this becomes minus J cap. So you have Q, V, B minus J cap, and minus J cap is the quantity that is for FB, the force due to magnetic field is in minus of J cap. J cap is minus of Y axis. So negative Y axis, you have got your FB vector in this direction, which is whose value is QVB. Okay. So now you will have to equate these two set of equation 2, and then you have QE is equal to QVB. QQ cancel, so we have E is equal to V into B, and we are studying about the velocity selector. What is that we are studying? Velocity selector. Velocity selector means by looking at the velocity, we can select the particles which is required for certain experiments to be conducted. That means your velocity remains there itself. So V is equal to E divided by B is the concept what you are taking. The same thing is given over here in this diagram, whether it is equal to E divided by B or not equal to E divided by B. That is the condition over here. The one which is not equal to is not used over here. The one which is equal to E by B marked in red, that is used for the certain experiment in order to bombard the charges into towards any nuclei of an atom. This is how we use this velocity selector. So by knowing all these things, we know that this equation V is equal to E by B, this equation is used to select the particle of certain charge, which this principle can be used in mass spectrometer, wherein you use the charge by mass ratio concept in order to select the velocity of the particle. So now we are getting on to something, a very beautiful concept under this velocity selector, and it is nothing but a cyclotron. We study about cyclotron. This is also a kind of velocity selector, wherein the particle that it selects, okay, the particle selected by this cyclotron will be used to bombard the nuclei of certain radioactive elements nuclei. Okay, so now you have this. This is a original image of the cyclotron, which looks like a cycle wheel completely. The cyclotron is said to be a cyclic thing which is having two Ds, and there is a gap which is present over here. You will see the schematic representation in the next slide. So this is the original image, like how exactly the cyclotron looks like. And now we have the construction. So here we study the construction theory as well as working of this concept cyclotron. So we have construction. In case of construction, we need to know that there are two magnets. Since it is a chapter where we are studying regarding the magnetism, and under that the concept what we are studying is cyclotron, you need to know it is an instrument which is having the presence of a magnets. So you have North Pole here and you have a South Pole here. So between North Pole and South Pole you are having a Ds, an instrument, call it as D1 and D2. If suppose you call this as D1, you can call this as D2, and these two yellow color representation, the cream color representation gives you the North Pole, wherein the between this dark yellow version what is there, that is nothing but your Ds, call it as D1 and D2. So the externally these Ds are connected to the oscillators. It is connected to a oscillator. Okay, so now we have two strong electromagnets, and these two Ds, D1, D2, these are known as Ds. Okay, these are connected to a external source, AC source, that is the oscillator, so which provides the alternating current, and it is a D-shaped cavity. That is why they are called as Ds. And there is this red color dots are nothing but the accelerated particles which is getting accelerated. And finally, this is also a south pole of an electromagnet. These are the instruments. It's very, very, very easy. Okay. Coming to the working now. How does this instrument work? Okay. So there is a ion source which is given. This is like ulta D and this is like actual D. So there are two Ds, D1 and D2. Okay. And there is a vacuum chamber which is surrounding this Ds. Okay. Two Ds. So in between there is a field over here and this is empty space. Okay. Where the ion source is shooted. So ion source is present over here. Call it as any charge which is shooted over here. So what happens? What happens in the sense when this cyclotron, Ds of this cyclotron is connected to a AC circuit or the alternating circuit, what happens? So here you have 2Ds, ion source. Now, the electric field is said to be supplied. Since it is alternating current, its polarities keeps on changing. Plus, sometimes this D1, suppose you consider this as D1 and suppose you this considered as D2. Now D1 polarity is said to be negative, D2 polarity is said to be positive. How does the electric field lines move? From positive towards the negative. So at the beginning, why this circular path is taken, why not any other direction? Because of the presence of electromagnetic materials, highly powerful electromagnetic materials whose strength is stronger, that is whose strength is larger, very strong magnetic poles have been placed. Because of those magnets, attracting condition of those magnets, the ion or the charged particles take the circular path. So here it has taken the circular path, okay, and in between this layer, that is between two gaps of between the gap of two Ds, there is a presence of this current, that is the current, electricity is supplied in between this. So what happens to the ionic charges which is present over here? When it passes through 1D, it gets accelerated at this part, okay, acceleration, that is from positive to negative. According to the very first chapter, electric charges and fields, you have studied that there is a passing of the ion in between the particles, that is the electric field lines flows from positive towards the negative. So this is said to be the positive and this side it's said to be the negative, so it is accelerated towards the negative. then again it takes the circular path because it is accelerated. That means there is change in velocity. When the velocity changes, there is a change in its distance as well, the radius as well. Okay, so now there is a path what is changed, and again now when the ion comes to this part, again the polarity changes. This becomes plus and this becomes minus. At that time the charge electric field lines passes from plus to minus, because of which it passes towards from this place, and again it takes a circular path. That is due to the presence of the magnetic fields at the top as well as at the bottom of this Ds. Okay, finally we end up with a final rotation over here, which in turn it is given a ejection space over here. As it ejects, the beam is allowed to hit to the target. Target might probably, we can take the targets as the nuclei of certain set of elements. So that is all about your working of the Ds. Okay, so now we are getting into the expression in order to know the working of the Ds. So now we have working, we know that the magnetic field, we know that QVB, the force which is acting on this particle is nothing but QVB, the magnitude of the magnetic field. And we also know that the magnetic field acting on an ion gives a circular path, and that circular path can be given as mv square by r. This is nothing but the centripetal force. Okay, equate this equation, equation 1 and equation 2. You have QVB is equal to mv square by r. Your v and v gets cancelled. Equate for v. V is equal to QBr divided by m will be the velocity. And or r, if you consider r is equal to mv divided by QB will be the concept. mv divided by QB. So now you have velocity as well as r. Now you need to know the time taken by a particle, that is the charged particle, in order to trace that circular path. You have t is equal to, you have pi r. Pi r is the circular, that is the circumference of the circle what you are considering. So it takes up pi r divided by the velocity. That is velocity, you know, velocity is equal to distance by time taken. You are considering time, so it will be distance divided by v. Distance will be the circular path what it is considering, divided by the velocity. You have pi r divided by v. Substitute for r, so we have pi by v. R substitution mv divided by QB. Your v and v gets cancelled. You have pi m divided by QB, which is equal to t. So t is equal to pi m divided by QB is the concept. Okay, so now this will be the time taken in order to trace the circular path. Suppose if you have a maximum velocity, when will your velocity be maximum? Apply for this equation. If you have v max, then you will have the radius also maximum. The velocity is said to be maximum only at the last circular path which is being read, okay, which is being traced, because as the radius is large, the velocity also will be larger for the particle. So what happens? You can rewrite this as V max is equal to, max means it is maximum, QB R maximum divided by, you have m, which is said to be the mass. This will be the maximum velocity for the maximum radius it traces. So now this can be written as V max is equal to QB R divided by m itself. So this equation can be considered as equation 3. Now we have equation 3 with us. So when a particle is undergoing action, what is that we have to check? We need to know there is a presence of kinetic energy, correct? So how do you give the kinetic energy as? Kinetic energy is equal to half mv square, wherein I want to equate for energy nothing but the v, that is the v formula, velocity, maximum. So it is v max. For v max, what is that we have? M divided by 2. So now m by 2, we have v square max is q square b square r square divided by m square. Square cancels with m, so we have q square b square r square divided by 2m as kinetic energy. So now we can write this as, now we will have to consider the time. As per our previous derivations, we know that time is equal to 2 pi m divided by qb. So now, what is the frequency? Frequency will be nu is equal to qb divided by 2 pi m. So, nu is nothing but the reciprocal of the time, that is frequency is reciprocal of time. So, when this is the equation what we have, we can rewrite these equations as we have kinetic energy. What is that we had got? M divided by 2 q square b square r square divided by we had m square. So this cancelled. So it was b square q square r square divided by 2m was the equation which we had given for kinetic energy, and the time period which was taken as 2 pi m divided by bq, and the reciprocal of it is nu 1 by t, which gave bq divided by 2 pi m was the concept. So now equate for BQ, you have BQ is equal to 2 pi m and nu. Okay, so now apply this, call this as equation 3. So this will be equation star. So now it is like you will have to take up the kinetic energy is equal to square this BQ square. So BQ the whole square, you can square these two. So 4 pi square m square nu square into r square divided by you have your 2 and m. 2 once, 2 twice, m 1 square cancels with this. So you have 2 pi square m nu square and r square. So this is the concept what you are having, that is the kinetic energy required for a charged particle in order to, this is just cancel once, okay, this is not there. 2 pi square m v square and r square is nothing but the concept, that is the kinetic energy which is required for an ion or the charged particles to move in the cyclotron. So this cyclotron is used to accelerate the charged particles and eject it through the open structure in case of that chamber. Okay, and finally through the exit of the cyclotron instrument, it gets ejected towards the target of any nuclei of any element. Okay, that is all about the working of this cyclotron. Now we are getting on to Biot-Savart's law. So in order to know the Biot-Savart's law, they considered a conductor and certain line element. Okay, in conductor they considered a certain line element from this point towards some point, call it as point P. If suppose this is considered O and OP distance, and this distance is at a distance R from the conducting wire. Okay, so now the line element which was considered here, this line element was called as DL. DL was the length of the line element which was considered in that conductor. So through which the current I is flowing, and that means the magnetic field which is affecting on this conductor is called as vector B. So now this makes an angle theta with respect to the conducting wire. The line, that is the point P, OP, makes a angle between the conductor as well as the line element, that magnetic field which is acting because of the line element. Then according to Biot-Savart's law, how is the magnetic field determined? dB, that is the magnetic field, is directly proportional to length of the current element, call it as DL. Directly proportional to length of the current element. This is 1 point. We have still 2 more points. Totally it is the fusion of 3 points. Okay, first of all, when you calculate this Biot-Savart's law, he is telling Biot-Savart's law, it is always about the magnetic field. So magnetic field with respect to this line element is called as DL. Back again, the magnetic field is directly proportional to the sine of the angle between them. So angle between them is theta. So you call it as sine of the angle between the conductor and this line is said to be sine theta. And finally it is inversely proportional to square of the distance, that is r, between those 2 points. Okay, so these are the concept. By having this concept, you can give it as dB is equal to, so directly proportional to the current element, it can be I into dl. So it is I dl, it is directly proportional to I dl sine theta divided by r square. So removing the proportionality constant, you have dB is equal to, you can remove and write it as nu naught divided by 4 pi into dl into sine theta divided by r square. Since you know nu naught is equal to 4 pi into 10 to the power of minus 7 Tesla meter ampere inverse. So this is the constant term for nu naught, that is permeability. So this is nothing but the absolute permeability of this free space. So this concept in case of your moving charges and magnetism is very important. Biot-Savart's law, and you'll have to explain it with the help of this diagram. So in today's class, we have studied about the velocity selectors, 2 types of velocity selectors, and motion of a particle when there is a presence of magnetic field, as well as the Biot-Savart's law. Let us all meet in our upcoming session with the same chapter, chapter 4, moving charges and magnetism. Until then, have a good day. Thank you.